Welcome to Autonomic Wellness, making stress easier to handle through science, balance, and a deeper understanding of your body.
Welcome to today's segment of the Th2 Immunological Dominance Solutions series. Within today's segment, we are going to discuss the impact that Th2 dominance has on other immune complexes, as well as those immune complexes potentiating the likelihood of Th2 immunological dominance. Before we get stuck into this segment, just a bit of a recap of what it is that we've gone over thus far. So the first segment was an overview of the immune system and how it is that it coordinates a plan or strategy to attend to variables such as pollutants or pathogenic variables such as antigens, in the differences as well as the communications between the innate and the adaptive immune system. In the second segment, we went into what warrant Th2 expressions ought to do. This was again in specificity to extracellular variables that are detected within our bodies. And then the third segment, we went into causative factors that can cause a dominant state of Th2 immunological dominance. So today we're going to go into the impact that all this actually has on other immune complexes or the immune system as a whole, going more into detail the nuances rather than the contributors thereof. With that being said, I'm going to be sharing my screen in one moment, within which you'll be able to view the PowerPoint slide associated to this presentation. At the end of the segment, if there are any questions, I'm most certainly happy to answer them. But with that being said, let's get started with the presentation. Okay, so the title of this presentation, the formal title, is Immunological Distortions Impacting Th2 Dominance. Okay. So firstly, what happens when there is Th2 dominance in the body? Then we touched upon this in our last segment. It doesn't just create the increased rise of histamine, which in itself can cause leakiness in the most deductive conclusion throughout the body, including that of increased intestinal hyperpermeability. In addition, histamine also increases as a key inflammatory response, as well as being an excitatory neurotransmitter can lead to excitotoxicity. Furthermore, the way in how histamine has an attraction and by mediating more extracellular immunologic vigilance, it also has an impact on downregulating cytokine release that is responsible for the regulation of intracellular detection and also in doing so, the body's ability to neutralize intracellular threat, one of which are natural killer cells. Natural killer cells are one of our two major forms of cytotoxic cells. They're innate cells that all stem from lymphoid stem cells, which makes them rather novel. As in all our other innate immune cells stem from myeloid cells, in contrast to natural killer cells, which do stem from lymphoid stem cells. Other cells of our immune complex that stem from lymphoid stem cells are our B and our T lymphocytes. And to consider why this is important is to do with the versatility that these cells have in being able to detect certain covert variables that may be otherwise gone undetected, such as cell wall deficient bacteria. Other covert operatives can also be things such as stealth viral reactivations, such as Epstein-Barr, within which, when there is a reactivated instance, can actually distort cytokine expression in inducing immunological vigilance or immunological tolerance rather than immunological action or reaction. And in that state of immunological tolerance, it may heighten tolerance to intracellular threat, but in heightened reactivity to extracellular variables, i.e., resulting in an increase of histamine release. So to that point, down regulators of natural killer cells and up regulators of Th2 dominance. So this doesn't just happen by its own. There are a multitude of variables that can actually contribute to how the body increases its Th2 response and reduces its natural killer cell response, and in doing so, reduces the body's capacity to clear out corrupted cells. Not only corrupted cells, natural killer cells also have the capacity to clear out extracellular variables. However, it's variables that are seemingly difficult to detect due to a lack of apparent antigen expression. So we really want our natural killer cells to be proactive because not only do they provide us with that initial protection against certain operatives that are more covert in nature, but they also provide us with the ability to review and detect any cells that have become carcinogenic. And in doing so, neutralize those cells from being able to replicate and further impact neighboring cells. So the health and the availability of our natural killer cells really protects us from cancer and certain common vector-borne illnesses, such as those associated to Lyme's disease. So chronic stress most certainly does downregulate natural killer cells. We have seen a decrease in the natural killer cell count as we get older. Elderly are being more so susceptible to common vector-borne variables such as mold, such as cell wall deficient bacteria. And to that, a lot of it has to do with the fact that there are insufficient natural killer cells creating a monitoring surveillance of what's going on within the person. So chronic stress absolutely is a contributor to accelerated aging as in stress mediates an increased demand of energy turnover. And in that demand of energy turnover, when that turnover isn't regulated for the right form of recycling of energy, as in how it ought to happen through the balance of the three major respiratory chain activities, that of our anaerobic glycolyses, tricarbolic acid cycle, and eventually into electron transport chain, when it is that we're demanding more immediate energy, we might find that there's a shortfall in how those processes do not lead into optimal sequence of one another to ensure the most efficient yield of energy output. So what we end up with is a more energy resource, but a lower energetic output, which means that we need to quote unquote rev our engine to a hotter degree to create the sustained energy requirement that we are putting on as a demand or whatever it is that we are asking of our bodies, whether it be that of a grueling workout or whether it be to fight an infection or whether it be just to contend with the ambition of our career objectives, whatever it might be, as in how it is that we regulate that stress really can either be detrimental or beneficial. But in instances of chronic stress, it most certainly dysregulates our respiratory train efficiency. And not only does that impact the mitochondria over time, but so too does it intimately impact our innate immune system to the point where we downregulate natural killer cells and we upregulate Th2 dominance. Stress also triggers the release of cytokines such as interleukin 4 and interleukin 5, which promote Th2 responses, exacerbating allergic and inflammatory conditions. Now, when we look into the endocrine association with the immune system, and we pair up the correlate between certain sex hormones and their probability to increase the activity of certain cytokine, it's really interesting to see the impact that estrogen has on interleukin 4, interleukin 5. You see, estrogen is a powerful hormone and it helps so many variables, especially that of the neuroendocrine aspect, in that it helps to manage and monitor not only the production, but the expression of our monoamines, that of dopamine and serotonin. So to that point, when it is that we have a imbalance or an excess of a particular type of hormone, this can not only potentiate a heightened stress response due to excess of excitation that can be mediated by a surplus of a particular hormone, but that through this may very well mediate a Th2 cytokine specific immunological response, again, leading to the exacerbation of allergic inflammatory conditions. With downregulating natural killer cells, chronic stress can increase cortisol levels, and that's really the cortisolemia that actually suppresses natural killer cells. And not only does it natural killer cells, but it also distorts mast cells and mucosal cell activity, of which over time can actually lead to a poor endothelial gradient. Specifically, the villi in our gastrointestinal tract can become quite stunted and short, reducing our capacity to actually effectively absorb nutrients, which in and of itself can lead to further compromise in our energetic efficiency, leading to a more dominant stress profile to create more immediate energy, because the latent processes are somewhat underpowered in not being able to effectively do so. Other variables include chronic viral infections. So chronic viral infections downregulate natural killer cells. These include the reactivation of Epstein-Barr, in certain instances HIV as a retrovirus. That can exhaust natural killer cell function over time. When it comes to Epstein-Barr, one of the ways in how it does so is by hijacking ribosomal machinery and in doing so producing a protein similar to interleukin 10, which is a cytokine that's meant to induce immune tolerance, not immune reactivity. But in that, increasing its immune tolerance can actually reduce the response necessary to address the actual viral replicative process, leading to the virus being unchecked in its continual replication, which eventually leads into an energetic debt in systems-wide metabolism. HIV is a little bit different in how it goes about distorting the innate immune system, hijacking CD4 cells, and in their hijacking CD4 cells, harboring the long lymphatic nodules, thereafter compromising our B cell antibody presentation capacity, which over time eventually results in an exhausted cytotoxic outcome. Both of these certainly impact the efficacy of our cytotoxicity, which is understandable because when it is that we have efficient cytotoxicity, these viruses ought not to be able to survive. So it is most certainly in their best interest, not in ours, to compromise a cytotoxic efficacy from our immune system. And also chronic viral infections also upregulate Th2 dominance, I mentioned before, often promoting a distorted protein complex. And in that distorted protein complex, the body is given mixed signals essentially. So it's given the signal not to look for things inside the cell, but yet the body knows that there's something going on that ought not to be going on. So when it is that the body cannot detect effectively, there's a certain cross presentation that occurs in which the extracellular response may heighten to the degree in which it is meant to, in theory, support an improvement of intracellular detection when it is that initial intracellular detection doesn't live up to the mark that it's ought to. The third point here is cytokine imbalance, and that also ties into what I mentioned before. So variables that downregulate natural killer cells, interleukin 10 and transforming growth factor beta. These are all cytokines that suppress natural killer cell function. And these particular cytokines most certainly can proliferate in certain Th2 dominant states, particularly interleukin 10. Regulators of Th2 dominance, both interleukin 10 and transforming growth factor beta, can favor the differentiation of Th2 cells and the production of Th2 associated cytokines like interleukin 4, interleukin 5, and interleukin 13. Continuing on with downregulators of natural killer cells and upregulators of Th2 dominant cells, which again, for those who were not present in the first few segments, are under the banner entitled polymorphonuclear leukocytes. Hormonal imbalances. Estrogen can reduce natural killer cell activity when it is in an unfavorable ratio to variables such as free testosterone or progesterone in women, or testosterone in women and men. Other upregulators of Th2 dominance are not only estrogen, but also an excess of T3 activity that is not supported with an optimal androgen profile. This most certainly can potentiate an exacerbated histamine expression. So it's a question of that, this is where things become quite interesting, and it becomes somewhat of a paradox in that we require T3 in order to support mitochondrial biogenesis and the recovery of Th2 dominance. Yet when it is that the body tries to compensate by upregulating its thyroid output, inducing a hyper state, this in and of itself can compromise sulfur metabolism, including iron cycling, of which testosterone and growth hormone form a really intimate role in the regulation there, specifically testosterone playing a big role in the antioxidant mechanisms in the cytosol of the cell. So it's a question of balance. It's not that estrogen or T3 proactively go out there to try and distort histamine expression, However, when it is that we are exhibiting an imbalance due to variables such as stress creating a decline in the availability of testosterone, which we know hypercortisolism to potentially do, this can lead to an imbalance of ratio of activity. And it's really about the ratio of activity that we need to concern ourselves with when it is that we're looking to create equilibrium in the immune expression. Estrogen does increase Th2 responses, which is why conditions like asthma or eczema can worsen during phases of hormonal fluctuation, such as menstruation or pregnancy as well. To the point about menstruation, women that generally struggle with symptoms of PMS, whether it may be emotionally stated or that of actual physical increase of heavy, painful period and blood flow, this often has an association to insufficient progesterone, or at least the pulse of the luteal release of progesterone to counterbalance the availability of estradiol. Now, estradiol has a lot of amazing benefits throughout the body. However, in certain instances, for example, when there's insulin resistance in place, one can find themselves to be in estrogen dominant state. So the lack of progesterone can often be mediated by ongoing chronic stress. But in that, often we find ourselves, men and women alike, consuming sugar to contend with that stress. And notably, the reason as to why we find ourselves veering for a pack of wine gums, or for those up in the northern hemisphere, a pack of Haribo, is because of the way in which insulin is inversely related to cortisol. So when it is that we're going through a lot of stress, the body forms a strategy in which it would know to be able to modulate itself. And by consuming sugar, you have a rapid, immediate spike of insulin, which drops cortisol momentarily. But because it's such a rapid spike, it also has a rapid response of insulin release. And once that insulin creates a disposal of that excess of sugar, that's when you get the seesaw of excessive cortisol coming back as a rebound. And then the vicious cycle of consuming unwanted foods, unhealthy foods, continues. Essentially, that can lead into insulin resistance if it is kept unchecked for a long enough period of time. And insulin resistance has been noted to increase aromatization of androgens into estrogens, as well as not necessarily for the right form of metabolism of estrogens, as we do have different metabolites. 2-hydroxyl estradiol has a very different effect on health in contrast to 4-16-hydroxyl estradiol. And sugar consumption plays a large role in that it also impacts the liver. Sugar being a very highly oxidative can lead to depletion of variables such as glutathione and other sulfur metabolic processes. So it is, again, when we're looking into dominance, we're not just considering that this happened out of the blue, but rather there are certain variables of stress in our lifestyle and diet that can arise from stress. I don't believe that anybody, is born and wanting to have an addiction to bad food, or is wanting to have an excess of body weight or weight loss resistance. But unfortunately, these outcomes are often byproducts from poorly regulated nervous systems in a day and age whereby our nervous systems are constantly stimulated, which is also why, apart from all the pills and potions of nutraceuticals and otherwise, or peptides or whatever one might be veering toward, it is imperative that one doesn't just substitute a pill for an ill, but also take an initiative to create parasympathetic response in one's life, whether that may be for going for a hike, meditating, or just doing charity work in a means that gives something back to the community as well as to ourselves. Moving back on, however, for today's presentation into the immune system and the physiological variables, other variables that can down-regulate natural killer cells include environmental toxins, so long-term exposure to environmental toxins like heavy metals, like air pollution, pesticides. Atrazine, as an example, not only does it suppress natural killer cell function, but it distorts the androgen expression, particularly in the brain, but in multiple mammal and albeit animal studies, atrazine has actually caused a difference in the preference of sex. You look as to how widely atrazine is used in modern day agriculture, this is most certainly a variable that we need to consider not only for our immune system, but also our endocrine system, which plays an intimate role in the regulation of our immune system. And when it comes to the factor of androgen receptors, Androgen receptors potentiate Th1 responses. So, in instances whereby you're having suppression, as an example, in the unwanted consumption or unbeknownst consumption of atrazine, this suppression of androgen expression most certainly leads to a potential downregulation of natural killer cell function, which impacts our Th1 type cytotoxic outcomes. Other variables here with regards to environmental toxins that upregulate Th2 dominance. Toxins are often linked to an increase of allergic conditions by enhancing Th2 mediated inflammation. Lead is a big variable over here, aluminium, which has been found in commercially farmed chicken, interestingly enough. There was a survey that was done on a bucket of KFC chicken to determine the concentration of aluminium in a family sized bucket. And what they found was 1,000 times over the water drinking limit. So it's not found in the most apparent sources, such as chemtrails in the sky, although that is most certainly a variable. I think it used to be conspiracy, it's now become more known fact, but it's also found in our fruit sources. So essentially, what it is that we need to consider is to really limit our intake of food that isn't sourced from organic sources, and really to invest in food that comes from truly organic sources, as well as nonetheless, even despite the fact that you might be buying organic, to utilize an enzyme-rich vegetable and fruit wash prior to consuming any produce. Again, in our day and age, there is a lot of cross-containment packaging that is utilized with both sectors of agriculture, both non-organic and organic. So when it is that you are consuming certain seemingly organic, you don't know whether or not it may have had exposure to the unorganic food sources, which often enough do have pesticides on their outer coat covering. This is one of the ways in which commercial farming ensures a greater yield of produce. So yeah, everybody should do themselves a favor, invest in a good enzyme, vegetable, and fruit wash, and just soak your vegetables and fruits in that enzyme blend for enough period of time before it is that you cleanse off any of the likely dysregulators impacting your immunoendocrine system. The other variable here, nutrient deficiencies. And this is an interesting topic here, as in one would think, if vitamin D levels are low, what should you do? Supplement with vitamin D3 specifically. That may seem logical, however, there's a bit of a nuance into that consideration. See, when the body has been in a chronic state of Th2 dominance for a period of time, often vitamin D receptors can be somewhat downregulated. Dr. Trevor Marshall spoke about this at length in a lot of his published work, in which he utilized antihypertensives, repurposed their use, specifically olmesartan, for the purpose to help reestablish vitamin D receptor sensitivity. The case studies that were represented were not RCTs or cohorts, so the conventional paradigm may have a bit to say about the validity of his having experienced the benefit that it can bring in resetting immunological tone by way of reducing inflammation, of which vitamin D receptor highly regulates the immune system's inflammatory expression. I can, for one, attest that it does have a lot of validity. Outside of the use of pharmacology, however, one need not only consider the extremes of antihypertensives if it is that vitamin D receptor sensitivity seems to be downregulated, but instead one can also consider the use of a compound called metadiacrol from a company called Nano, which is a polycosanol. It's a wax that is derived from sugarcane. And essentially, what it does, it actually provides the vitamin D receptor renewal, sensitivity renewal, albeit taking longer than perhaps the Marshall protocol. One could, however, consider combining both interventions, as there isn't any contraindication to do so. But the point I'm emphasizing here is it's not just a question of replenishing a deficiency, it's also a question of considering how long that individual or that physiological state has been deficient and what potential maladaptive outcomes have resulted in that deficiency. Undoubtedly, once it is that you start to support the receptor in being receptive, then definitely renew and replenish what it is the body is lacking. However, if it is that you are prematurely reintroducing these compounds and there's an excess left in the extracellular space, such as that of vitamin D, this can actually heighten the exact opposite of what we're looking vitamin D to do. As an example, increasing lipid peroxidation and the production of peroxynitrate when it is that there's an oxidative impact onto vitamin D due to lack of uptake through the vitamin D receptor. A little bit of a diagrammatic construct here of what it is that we have discussed thus far. So chronic viral infections, reactivation of those viral infections, and just make sure to note that a suppressed natural killer cell availability is not only the outcome of these chronic viral reemergent patterns, but it is also the contributor to their initial reemergence. As I mentioned before, one of the biggest variables to lower our natural killer cell is that of stress. And as we get older, due to variables such as declining hormones, due to the variables of compounded exposure to toxins such as heavy metals, petrochemicals, and so on, our capacity to tolerate stress declines, but so too does our immune system decline its efficiency of its natural killer cell cytotoxicity. And this is also a reason as to why those who are more vulnerable to viral reactivation patterns are generally those in their later years. Not to say that they're exclusively so, but there are many a young individual also experiencing herpes flares and so on. But when we look into their lifestyles, we can often note that it is coming about from a bout of stress or a moment of stress that can induce so. Cytokine imbalances, it's bidirectional, they can most certainly induce Th2 immunological dominant state, but they can also be the outcome thereof. Nutrient deficiencies, environmental toxins, hormonal imbalance, and chronic stress. And interestingly enough, in order to, what do we do first, or which comes first, the chicken or the egg? Do we provide the body with the right type of nutrients in order to get our endocrine system back into balance? Or do we provide our body with the right type of hormonal support in certain instances in order to get the nutrient deficiencies out of the equation and nutrient efficiency back into balance? And the reason why I mentioned that is not just a question of putting something into the body, it's a question of improving upon how I can utilize those variables, which by way and large is highly dependent upon the endocrine efficiency, not just that of sex hormones, but the entirety of the endocrine system, specifically the gastrointestinal endocrine system, which plays an intimate role or is intimately correlated to the activity of our nervous system. As and when there is a dorsal vagal dominance, this may compromise hydrochloric acid release from the parietal cells in the stomach, as just one of many other examples. So it is a question of how do we improve upon our nervous system's hormetic bandwidth. And that has a lot to do, in my opinion, with the state of our hormonal or endocrine health. Again, just to reiterate, vitamin D in particular plays a role in modulating immune responses, as well as hormonal production, as well as many other variables. Yet, within the purpose of this presentation, it does most certainly have an impact in modulating innate immune status. It does help support the production of lymphocytes as well, and as well as improving upon cholesterol metabolism or synthesis. We need vitamin D in order to produce cholesterol, which is required as a base substrate to produce all of our sex hormones. So if we lost the efficiency, in particular to produce enough HDL, this can often be seen due to either vitamin D receptor resistance or insufficient vitamin D levels. Deficiency can lead to a more pronounced Th2 dominance for obvious reasons, as to what I've just mentioned, potentially contributing to allergic or autoimmune conditions. Neutrophil and extracellular traps. So what are neutrophil extracellular traps? Neutrophil extracellular traps are the byproduct of an excess of neutrophil activity, which is mostly mediated from a Th17 response. And I know some of you are asking, but aren't we discussing Th2 immunological dominant solutions? We are, but the knock-on effect that Th2 immunological dominance has is not just by way of cytokine specific to Th2 dominance, but also can facilitate the increase of Th17 activity. Now, Th17 activity, when it is heightened to in a dysregulated state, it has the correlate to increase the likelihood of pathology, including that of multiple sclerosis, ankylosing spondylitis, lupus, and many an arthritic condition as well. So when I consider Th2 dominance, I see it as the prequel of which the innate immune system is often in a state of auto-inflammatory expression. And if that prequel is left unchecked, it becomes the main feature, which can lead Th17 into a dominant state, which can create a conversion or an evolution, in this example, from autoinflammation into autoimmunity. So when we look here into extracellular traps, one of the variables in how that this contributes to all of this is that like an excess of neutrophil activity eventually affords the production of a web-like collagenous structure that actually has DNA, histones, antimicrobial enzymes like elastase or myeloperoxidase in it. But these particular enzymes are quite pro-inflammatory. So essentially, the rationale as in why the body would do so is to widen the net to capture something that it can't readily detect. So that basically increases its chances. It's like laying multiple bets along the roulette table instead of putting all your bets into one block. But in this, not only is it going to be impacting the pathogen in question, but it's also going to be impacting our own innate cells, leading to chronic inflammation. So just a little bit of a line diagram here. Th17 activation leads to an increase of interleukin 17, which impacts the epithelial, stromal, endothelial activation, which causes an increase of chemokine release. Chemokines such as CXCL13 as an example, CXCL5 is yet another one. These increase neutrophil activity, an influx of neutrophil activity, which causes priming to the increase of neutrophil, the production of neutrophil extracellular traps. Th2 dominance in inducible Tregs. Okay. Th2 cytokines, interleukin 4 and interleukin 13. Th2 dominance creates an environment that indirectly suppresses the differentiation and stability of inducible Tregs. These are our adaptive pacemakers in the immune cell. They provide tolerance. They provide modulation to activity in both the innate and adaptive, but specifically the adaptive expression, and in doing so help to regulate the degree of apoptosis and cytotoxicity so that we do not leave our cytotoxic cells unchecked to create widespread apoptosis or the instruction to infected cells to commit suicide. Otherwise, you have an entire colony of cells committing suicide, leading to necrosis or the potential necrosis. So in this example, Tregs are really important to prevent the likelihood of necrotic tissue. But yet, in their expression, they can also stabilize not only cytotoxicity, but also to that of exacerbated histamine release. As we know, exacerbated histamine release can potentiate fibrotic tissue buildup in certain extreme cases, inducing outcomes such as emphysema, and not so extreme cases, but leading to potential serious pathology, fibrosis of the microvasculature. With that, interleukin 4 and interleukin 13 can inhibit one responses, which otherwise regulate inflammatory cytokines like interleukin 6, indirectly reducing the regulatory function of inducible Tregs. The Th2 dominant milieu may also lower interleukin 10 levels, further limiting inducible Treg mediated suppression of pro-inflammatory pathways. So interleukin 10 doesn't potentiate Th2, but in its increase, it does downregulate Th1. So it's not interleukin 10's increase that can mediate the consideration of Th2 dominance, but rather its increase in combination with other cytokines such as interleukin 4, 5, and 13 that warrants consideration as to what might be potentiating, reducing intracellular immune tolerance and extracellular immune reactivity. The impact on inducible regs and Th17 balance. Inducible Tregs are essential for suppressing pro-inflammatory cytokine production, including interleukin 6. So interleukin 6 is not unequivocally classified as a sole Th2 cytokine. It is expressed in multiple Th states, Th1, Th2, Th17. However, when there is a high degree of interleukin 6 that is being simultaneously expressed alongside Th2 type cytokine, this creates an increased probability of potentiating use the Th17 outcomes. Some of those cytokine also include interleukin 21 and interleukin 23. So generally what will happen is when you have a high degree of transforming growth factor beta and interleukin 6, this can actually cause certain other innate immune variables like macrophage to shift the innate immune paradigm by stimulating other B cell specific, or T, which is to be more specific, follicular B cell activity to release more interleukin 21 and interleukin 23, which eventually results in an increase of Th17 response, neutrophil influx, leading to an increased probability of neutrophil extracellular traps. So essentially, we really want to keep our eye on interleukin 6. Other variables that can increase interleukin 6 are not just that of the immune expression, but also metabolic status. And as in metabolic resistance, especially in obesity, has been noted to, or those whom are experiencing obesity have been noted to have elevated levels of interleukin 6, which only further increases the likelihood of Th2 mediating Th17 probable outcomes and its associated autoimmune expression. This imbalance shifts transforming growth factor beta pathway from favoring inducible Treg induction to synergizing with interleukin 6 to drive Th17 differentiation. So essentially, TGF beta plus IL-6 is what mediates an increase of IL-21 and IL-23. So it is in isolation an increase of TGF beta, which we know in previous slides I mentioned has association with Th2 dominance. If its expression isn't coupled with a heightened interleukin 6, the likelihood of it inducing Th17 differentiation declines dramatically. But again, when there is interleukin 6 elevated alongside that, we have an increase of interleukin 21 and interleukin 23, of which that quadfecta leads into an outcome of Th17 differentiation. Th2 dominance and continuing on with neutrophil extracellular traps. Okay, so interleukin 6 driving Th17 differentiation. Interleukin 6 works with transforming growth factor beta, promoting Th17 cell differentiation by activating the transcription factor related orphan receptor gamma isoform T. Raw gamma T, as I like to refer to it as, is the master regulator driving the development of Th17 cells. In addition to that, it's also STAT3 that comes into play here as well. So it does drive both raw gamma T, and in that, driving an increase of STAT3, which increases Th17 and T follicular helper cell activity as well, all of which can massively induce fibrosis throughout the body. In the absence of adequate inducible Treg suppression, interleukin 6 transforming growth factor beta signaling dominates, favoring a Th17 response. Th17 cytokine profile and outcomes. Th17 cells produce interleukin 17 and interleukin 22. Now, it's really important to consider what it is, what type of cytokines this particular state induces the production and expression of. And the reason for that is when we look to augment immune or particularly chronic immune states, we can note that certain hormones, as an example, testosterone, has a very powerful capacity to downregulate interleukin 17 and as well as interleukin 21. Whereas growth hormone, human growth hormone, has a capacity to modulate directly interleukin 22 and interleukin 20. So essentially, when we have a immune status as well as a cytokine map, and I would always recommend pairing both of them when it is you're trying to determine where it is a person is on the immune spectrum. And we can note that there is a high probability of Th17 activity. we can utilize hormones to our advantage here in order to regulate immune status while it is that we're removing the drivers causing that dysregulation. And I think this is where there's a lack of implementation within the industry, is that we are wholly focused on removing mold, dealing with Epstein-Barr or herpes simplex viruses, or continuing with parasites. And yes, we should definitely do what we need to in order to remove those variables from the body that ought not to be there. Yet it's so much more comfortable for the patient to be able to do so, to have energy to go through that process rather than trying to flog a dead horse, of which many of people actually feel like when they're in these states. And one way in which we can do so is to actually support the endocrine system by creating a certain availability of hormone that can suppress a certain cytokine expression. Now, some may say, but this doesn't, isn't that going against what the body is trying to do? Well, it might be, but again, it's not a question of the body expressing itself in a warranted way, but rather we're leading into the point where it's expressing itself in an unchecked, unregulated way. Its homeostatic reception has become distorted, essentially. And in these instances, bioidentical hormone therapies can play an intimate role in creating a rescue to energy of which is required in order to induce any antimicrobial strategy or detoxification strategy. And interleukin 17 recruits and activates neutrophils, causing tissue damage and procoagulant state through tissue factor expression and fibrin deposition. Interleukin 22 has dual roles. It can either promote epithelial repair or contribute to barrier dysfunction and chronic inflammation, depending on the context. And the context is really dependent upon the other cytokines that are expressed in its expression. So often it is a symphony that creates the melody to immunological activity. And in this, interleukin 22 coupled with interleukin 6 most certainly can lead to more chronic barrier issues, such as that of gastrointestinal hyperpermeability. Neutrophil activation, interleukin 17 promotes the release of neutrophil activation proteins like tissue factor and inflammatory mediators such as reactive oxygen species and proteases. Neutrophils exacerbate fibrin deposition and tissue damage, further sustaining inflammation. Th2 and Th17 pathway interactions. While Th2 and Th17 pathways typically counter-regulate each other, chronic conditions may enable simultaneous activation with inflammation driving overlapping immune dysfunction. So, in a healthy, warranted response, yes, they would have a counter regulation to one another's expression. However, in a dominant state, whether it's Th2 dominance or Th17 dominance, a spillover can happen in which the next state also becomes hyperactive in its expression. Okay, traps and fibrin accumulation. Okay, neutrophil excited traps act as a sticky DNA protein scaffold that traps fibrin, platelets, and this is also can be seen in platelet destruction. So if it is that you're finding that the patient might have initially low platelets, or actually, sorry, initially elevated platelets with eventually exhausted platelet availability, this can often be associated to an excess of neutrophil extracellular traps. A way in which to break down neutrophil extracellular traps is similar to how we break down biofilm as well as proteins such as spike protein through the use of proteolytic enzymes and supporting the body's efficiency in the production of glycosaminoglycans. Going back to this, red blood cells can also be trapped. This can lead to states of anemia despite adequate consumption of iron, despite adequate consumption of B vitamins and copper, yet still finding that the person is exhibiting signs of anemia. And this is really important to not only take into account the labs, but also the symptoms, because the labs can sometimes show on a serum concentration that red blood cells are not problematic, yet from a symptomatic perspective, there are all the signs of anemia. And this often is a hidden variable in distorting the truth of how it is that the body's not utilizing red blood cells. However, there are certain markers that can give you indication apart from your standard red blood cell. And those markers include erythrocyte sediment rate, And that's the one that comes mostly to mind. But that's probably the most pressing marker. It also binds into coagulation factors, helping build inflammatory clots. Okay, so if it is you find that your patients or yourself exhibiting a high arthrogenetic index of plasma, consider that there might be an excess of neutrophil or excess activity of neutrophil extracellular traps happening within the body. Fibrin then reinforces the neutrophil extracellular trap structure, making the clot denser, more stable, and harder to break down. And this is really important because this impacts the microvasculature, which is very much a disruptive variable on our thyroid mitochondrial response. And this is where we can have cellular hypothyroidism, albeit that the thyroid levels on our blood panel may be adequate, yet we still are experiencing, or the individual in question still experiences symptoms akin to hypothyroidism, which include but are not exclusively limited to constipation, coldness in the extremities, thinning of the lateral eyebrow, thinning of the hair loss, depression is a very big outcome to a poor T3 mitochondrial response. When it is that thyroid, or specifically triiodothyronine, cannot reach or efficiently reach and stimulate the mitochondrial uncoupling protein 3. This leads to a compromise in the proton pump gradient and the efficiency of OXPHOS4 to facilitate a yield of output of ATP. So this is where you can find labs to show signs of poor intracellular copper, which again, neutrophil activity, when it is heightened to this degree, can actually sequester copper from the intracellular space into the extracellular compartment in order to support its oxidative impact in trying to address a threat variable that it perceives it ought to address. When we do find ourselves in a deficient intracellular state of copper, this impacts variables such as cytochrome C reductase, leading to premature leakage of cytochrome C, which only further mediates more neutrophil activity. So the cycle can be quite vicious and compounded, being negatively impacted, further potentiating through their cell danger response an increase of neutrophil activity or heightened neutrophil activity. So just to come back to the slides here, altered thyroid hormone delivery, fibrin-induced microvascular damage limits the transport of T3 to cells and mitochondria. Reduced thyroid hormone delivery diminishes the availability of T3 for mitochondrial receptors, which are essential for modulating energy metabolism. So essentially, if we don't have energy, we cannot support enzymes, which are required for everything from detox to production. We cannot support our immune system, and it eventually leads us into a state of immunological exhaustion, of which the little bit of defense that we're trying to put up actually just falls flat, leading us into a state of increased vulnerability of pathology. Other variables that low T3 mitochondrial receptor response can facilitate is endothelial-related cardiovascular disease increase. Fibrin accumulation contributes to endothelial dysfunction by promoting inflammation, oxidative stress, and vascular stiffness. And atherosclerosis is most surely related to poor cellular thyroid activity. Often, when it is that I see elevated lipids, there may be genetic components to it. It's always important to factor that in, look at the ratios of lipids rather than them in isolation. But when it is that we look into ratios and the distortion between HDL and LDL, or your ApoA1 to ApoB ratios, and your VLDLs, and your small particle lipo LDLs, and you take the whole equation into account, more often than not, there is adequate thyroid, but there's poor adequate signaling of that thyroid. And it has very, very often been associated to this innate immune disruption of neutrophil, or in inducing a hyperneutrophil response. Now, also the things can be somewhat elusive when you look at a standard CBC white blood cell differential, is that you may not necessarily see in that an increase of neutrophil to lymphocyte ratio. 8 times out of 10, you, in my experience, but the 2 moments out of 10 or 20% of the time that you don't, it doesn't necessarily rule out that that isn't what's going on. And that's the reason as and why in later segments I'll explain what testing is preferential in order to determine the probability of any of this happening rather than just the standard quo complete blood count. It's always good to start with CBC because of its cost efficacy and efficiency, coupling that with a detailed symptoms analysis. We utilize a 364 question questionnaire, of which each question has an association to a particular physiological function and system. We review, investigate, and compare and contrast answers provided for on a Likert quantitative scale, albeit that it's a subjective experience, to that of the diagnostic findings of a standard panel. And when it is that there are anomaly in that contrast, then we warrant further investment to do deeper analyses through lymphocyte flow cytometry and cytokine analyses as well, pairing the two together preferentially if possible, as opposed to doing them in isolation. However, if it's not available to pair, then one is better than none. Reduced thyroid hormone delivery, as mentioned, reduces mitochondrial receptors, which are essential for modulating energy metabolism. So if you don't use it, you lose it. And this really is true when it comes to thyroid receptors in the mitochondrial space. So a lack of stimulation eventually reduces the availability to be stimulated. Okay, and this can lead to mitochondrial insufficiency. It also impacts the capacity of the body to induce mitochondrial biogenesis and recycle aspects of damaged mitochondria into new healthy mitochondria. Of all the hormones, T3 is mostly responsible for mitochondrial biogenesis. So when we don't have sufficient T3 signaling, we also limit our capacity to replenish and renew our mitochondria. The other impact of fibrin impact on T3 and mitochondrial response is that endothelial dysfunction compromises the transport of thyroid hormones across cell membranes and reducing intracellular T3 levels. Mitochondrial dysfunction from inflammation, fibrin deposits exacerbate local inflammation, and increase reactive oxygen species, further damaging mitochondrial membranes and receptors. Mitochondrial T3 receptors become less responsive in inflamed and oxidative environments, impairing the hormone's ability to regulate energy metabolism and thermogenesis. Impaired lipid and glucose metabolism, mitochondrial under T3 regulation are pivotal in maintaining lipid and glucose metabolism. A couple of this actually has to do with sex hormone binding globulin. When there is insufficient T3 signaling, we might find ourselves producing less sex hormone binding globulin. That's what's actually required for insulin sensitivity. An excess of sex hormone binding globulin can actually reduce androgen signaling, absolutely, but an insufficient availability of sex hormone binding globulin also has detrimental impact onto our cellular insulin sensitivity, as in sex hormone binding globulin is a needed protein to actually improve upon the production of Th2 transport proteins, which are specifically utilized in order to ensure insulin sensitivity in muscle contraction and tissue. And so if it is that we have insufficient sex hormone binding globulin, this is yet another not so apparent proxy that one can consider when reviewing the entire case for the probability of cellular insulin resistance. Back there again. Going back to fibrin's impact on T3 mitochondrial responses, fibrin accumulation disrupts these metabolic pathways by limiting T3 action, contributing to metabolic inflexibility and energetic deficits. It really does have an impact on the membrane space, which is really important for the shuttling of electrons and the support of doing so. Essentially, a lot of our enzymes that are utilized in order to support the electron transport chain are contained in the outer membrane space, which fuels back into the chamber for the production of electron transfer. So when the membranes essentially become rigid, there's a lack of enzymic reaction that occurs in our mitochondria, which leads to insufficient outcomes of oxidative phosphorylation. And oxidative phosphorylation is also highly dependent upon the initial availability of precursor metabolites such as pyruvate, acyl coenzyme A, and NAD, FAD. So when it is that we have insufficient hydrogen to pair up with NAD or hydrogen to pair up with FAD, this most certainly can compromise the mitochondrial flexibility. And the less flexible our mitochondria are, the less capable they are in producing energy. And that is the end of this segment. I hope it is that you all enjoyed this week's presentation on Th2 immunological dominance solutions.
Thank you for joining us at Autonomic Wellness. We hope today's insights bring clarity to your health journey. Until next time, breathe, balance, and be well.